Good morning, everyone. So today we will be doing sorting algorithms in our week 3 class, right? So sorting algorithms, we will do selection sort, insertion sort, bubble sort, merge sort, and quick sort. So like in interviews, what happens is that you won't be exactly asked everything, but it's better to know every kinds of sorting algorithm so that you get that intuition, right? And we are targeting that thing only in this course, right? So like in general, like this is the most efficient way, like the merge sort is the most efficient way. And so I mean majorly questions are like when you are doing the DSA questions, most of the time you will be applying this. Sometimes you have to apply bubble sort as well, so it depends on situations, but we will be like this will be focused on the algorithms, right? So starting with the selection sort. So let's start sort. Just hold on. Why it's not coming? Yeah. Okay. Let's just use this. Yeah. So selection sort. So by sorting in general, what we mean is that we need to sort the elements of any of the array in ascending form, right? So in selection sort, what we exactly do is that just keep these points in mind. What we do is that we like select minimum minimum and then swap, right? I will be explaining this. Just these are just the thumb rules which you guys should know. I mean, with every sorting algorithms I will be telling just one line sample, right? So starting with, like, let's say that we have an array, right? We have an array which is like 13, 46, there's 24, there's 52, there's 20 and 9. Fine. And they are like 0, 1, 2. Let me also index them, right? So we need to basically sort them using selection sort algorithm, right? So the first, like, basic thing that if this gets sorted, what will be the sorted form of it? It will be like it would be just, it will be like in this way, like the 9, 13, what will come, that 20, 24, 46 and 52, right? So this will be the sorted array. So we have to make this array in this form, right? This is what sorting means, but using selection sorting, right? So what we exactly do is that we will, like, as I have written here as well, select minimum and then swap, right? So to implement algorithms, like I will be writing these small things, and you know what, like just to implement any kind of algorithms, you need to have that observation pattern to form that code and all, form that logic, right? So first, I will just tell you the basic logic of it. First, in this array, we will find what exactly, let me write it in a better way. So let's say that we have this, and our indexing is like 0, 1, 2, 3, 4, 5. Actually, I'm like for the first time using a writing pad, so things might get little bit messy, but yeah, just I'm just practicing right now this new writing pad which I got, right? So yeah. So starting with this, what we do is that we first find the minimum, like first the minimum, and then swap it with the existing one. So what is the minimum in this? It's 9, right? So we need to swap 13 and 9. So what will be the, like, the next form of the array? It would be simply, I will just copy paste it right here, and you can write here 9, because I have just swapped the indexes, right? So this will be basically, this will be my second pass, second step, right? Now, like, this is done. So 0 index, till 0, 0, 1 thing is done. Hence now we move to the first index. Right, now we have to check what is the, like, we will just consider this search space, right? So here, what is the minimum one, and you need to swap it with the this first index. What is the minimum one in this part? It is 20, right? So again, you will, what you will do is that you will again copy paste. I will just swap 20 and 46 because now we are, our search space is basically this, right? 20 and 46, right? So this will be now coming to the next step. So 0, this and this is done. Wait, I just did some mistake here. 9, 13, and this will be coming here, right? Not 20. Sorry. Just hold on. My silly mistake. 946. So again, going here. What is the smallest one? 13 is the smallest one, right? So 46 will go there, right? So this is what we have to do now. So we need to swap 46 and 13. Just picking up the minimum one and swapping it, right? Now 9 0 9 13 is done. Now we will still again reduce the search space, I mean just the consideration space, right? So here it will be 0 1 like 2 3 4 5. So we will only see this kind of this part of array. What is the smallest one in this? It's 20. So swap it with what? This term 2, because we are decreasing it, right? So again I will quickly copy paste this and I will just swap it, right? So this will be 20 and this will be 20. You guys are seeing the pattern right now. This is the pattern. We have to pick up the minimum. We have to reduce the search space as well. So this is done, this is done, this is done. Now we have to search here. What is the minimum in this? 24. Swap it with 52. Easy. Just that. Again, quickly I will do this and 24. Okay. 52 will be swapped with 24. 24. Done. Now this done, this done, this done, and now checking with this. Again, simple swap because the minimum should be 46. So hence now finally we got our sorted array. So this is how 46. Let me complete it. This is how selection sort exactly works. So this is the algorithm, right? So now you need to code it out, and that's the tough part now. Like I have explained you the logic exactly, like we have to reduce the search space and all. So now comes the part of finding the pattern. So whenever, just note this down, like whenever you are, or let me just write it here, like whenever, like basically my point is that observing pattern, you guys should have the observing power, right, to form the algorithms right now, like looking at the logic and then writing out the code, forming the algorithm with it. So observing power is really important in these cases, right? So now we will code it out. First I will also tell what exactly we did here, right? So in the first case, what we did, we I will just write it right here. What we exactly did. So we swap at index 0, uh, and till, like, what was our search space? Till it was 0 till n minus 1, right? N, where n is the, basically n is the number of elements in array, right? So that was the swapping happened between 0th index to the n minus 1 element, right? In the next iteration, what happened? We reduced our like we reduced our search space also, right? So swapping happened at index 1, right? 1 till n minus 1, right? I will just write it exactly like here what we did, right? You guys can now, you can see, like swap at index 0 n minus 1, the our search space was 0 to n minus 1. Here index 1, our, like, this line is basically means that our search space was like this. Now coming to next one, what was happening here? Here we did the swapping with what? With 2, and starting from 2 to n minus 1. So basically we are forming the loop, we are decreasing the loop size and the swapping indexes, right? Reducing, it is reducing. Again, this is what we did in the last terms, and till now, like the last, what happened in the last, we can, I mean, for any kind of we are generally just writing a generic form, right? So I can write like swapping at index, let's say n minus 2, and it was like n minus 2, it happened to that one, right? Because the last element, if there's only one element, we don't need to swap. That's why I have written n minus 2, sorry, n minus 2. This will be n minus 2, and swapping will happen, the last swap will happen at any kind of array, will happen at this, right? So now you guys can see the pattern right here, like this is the pattern, right? Now we just need to write it in a in an algorithmic way. If you guys still didn't like understand what is exactly happening here, basically what we are doing here, like first our search space was till 0 to 5, then what happened, 1 to 5, then what happened, it got reduced 2 to 5, 3 to 5, 4 to 5, and then when one element comes, we just stop the swapping, right? Basically this is what we have to code right now. So I'll just provide you guys a uh, basic pseudo code for this, right? I will just hold on, this will, yeah, observing power. You guys just note this down. Now coming with the code one, so I can here what I can write, I can start with, just hold on, why this, yeah. So what I can do is that I can first write a for loop which with I is equal to 0, and I should be equal to or less than n minus 2. Why n minus 2? I will tell you. I have explained that, but I will still tell you, explain you guys again. For now, just consider this for loop, right? We can have one int mini as I, like just we are just considering for now that minimum is the I, right? Minimum, and then we will run one more loop for int j is equal to, which will be like j is equal to I, right? And I can write it as say this n minus 1 again, because the inside loop is running like in this way, and we can increment it, right? So selection, yeah, and if if array of j, right, if the inner loop is greater than the swap the outer, I mean, we are just finding out the minimum term, right? So first we just assume that mini is the minimum term, I index is the minimum term, but now if j is minimum, like is lesser than I, then the new mini would be j, right? It's just simple logic, like simple. If you guys know how to, find out the minimum element in an array, then you can do this. And then if this exists, we just need to swap it, right? Swap the minimum swap the mini with the array I, because array I is here is like the greater one, right? So we just do this, and then yeah. So this is the basic pseudo code for the selection sort, right? You guys, if you guys are doing CPP, if you guys are doing Java, you guys can code out on your own. And the time complexity, yeah. So time complexity of this is basically I will just tell you the what is the time complexity. You guys can just go out and search how it is. So like if you guys analyze it and all, the final time complexity would be something like this. But again, as the rule suggests that we need to ignore the we need to just consider the dominant terms. So this will be removed, ignored, and we need to also ignore the constants. So this will be included. So basically, final time complexity becomes O of n square. Got it? So this will be the time complexity, right? So this is the pseudocode, and yeah, why n minus 2? Again, why n minus 2? Because we need to, because here you use your swap at index n minus 2. The swapping will happen till n minus 2 only, right? Not n minus 1. This is n minus 1, the last element, because number of element is 1, and we start from 0, right? That's why n minus 1. So swapping will happen till here only. If the if the consideration of space comes here, this is a single term. How will it get swapped, right? If I j comes here, there's nothing there. No swapping will happen basically. So hence we are just considering with n minus 2 here, right? And mini mini is considered just to see that, let's say I is minimum, and if there's some element of j which is even lesser than I, then the minimum will be j, and that this is what we have written. And then if this happens, then just swap it, right? And the existing array, like even the space complexity of this would be O of n only, because we are just sorting the already existing array. So you guys can write the space complexity would be also O of n. Right, got it. So yeah, so please, like, with after every algorithm, please try to code it on your own in your own preferred language, right? So this will be your homework to code it out on your own. Here we are just seeing the approach. I don't want to make this whole course for a particular language, hence I will be just uh, writing the pseudocode for now, right? As we do the questions, if I discuss some questions, then I may, do a proper choose a language and then code, right? So this is what selection sort is. Now coming to bubble sort, so this would be a little fun. As you guys even saw that that was taking O of n square, right? Like it is way much like the world. It's very, it's bad time complexity, right? It's taking a lot of time. So as we discuss the algorithms, we will go to more efficient way. But for now, like, let's just discuss the bubble sort right here. Bubble sort. So in bubble sort, yeah, just hold on. In bubble sort, what happens is that we need to basically, again, I will just write a small, small line for uh, just for your knowledge, that here it deals with the adjacent swaps, adjacent swaps, right? So whenever you guys encounter with bubble sort, just remember adjacent swaps. That's why I'm writing it like after every sorting algorithm, I'm writing a particular word, like small line, right? So adjacent swaps will happen. How will this happen? Let's just discuss that. So first I will just consider one array, like 13, let's say 13 46, just a random array. We need to sort it. 24, 52, 20, and then something 9. Fine. I will increase it as well. Yeah. So, like, we will be doing the adjacent swaps here, right? How will that happen? Let's just see. Like, we will be starting from, we will take the consideration from the first and second element. We will see if this is sorted in a way or not. It is sorted, right? I mean, 13 should come before 46, right? So there's nothing to worry about. So we will, it's like sliding window only, but not exactly sliding window, but just try to visualize it like a sliding window. So we will, slide it here. We will see 46 24. Is it following the sorting order? No, 24 is small, right? So the new, so hence we will, swap these two values, and the new uh, will be formed, new array will be formed here. Basically we'll edit out 24 and 46. Exactly, this will happen. Now again, like shifting the, this thing here, 46 52, is it following? Yeah. Now again, checking here, is it following? No, because 20 is smaller, right? So again, these two values will get swapped. These two values, these two values will get swapped, right? So what will it form? New one. It will form like this, 52, and then here will be 20. Got it? Now 1342. Now last space, last thing to consider, 52 9. Again, we need to sort it because 9 is much smaller than 52, right? So new updation will happen, 52, and this will be 9, right? You guys can now see like how the what is the pattern exactly, right? Again, now this is not sorted, right? So again we need to perform this, again we need to consider this, but now we can see that if it is already sorted from this end, why we need to, again doing the window, again considering the window here? Can't we just start from 46 to 20 if this and this is sorted, right? So this is what we need. We will be, we won't be repeating steps here. Like, just to, just remember to make any kind of, to make any kind of algorithm more efficient, right? Always always try to like reduce the repetitive steps, right? This is a thumb rule for any kind of algorithm. If you need, if you guys like need to improve the time complexity or make it more efficient, always try to first find out what is the repeating steps and try to remove it. So here we see that if we do this if we make a loop of this thing and make it again, so this will again consider the window from this end, but we know that this is already sorted, so why even considering the window? Why can't we just start from here, right? Hence we will start from here. Now new array will be formed, I mean new operation will be done here. We can see if the window starts from here, 46 and 20 will be swapped, right? So 46 and this will be 20, right? And again the window will shift, here. Again we will be like, okay, 46 and 9 should be swapped, right? Yeah, so here I will swap 46 and 9. Now again last window here, we will again do the thing, we will again swap it, right? 46, uh, oh actually there's no sorting needed because it is already sorted, right? Yeah, sorry, my bad. Yeah, now again we can see that wait, I think I missed something. 20, 46, 29, yeah. So we can see that. So here actually what happened is that I said that we don't need to consider it here, but we can see like 20 is again conflicting, right? So we can't see this is sorted, right? So like I messed up actually, like when I was explaining this step, but as I came to know that we are seeing this thing 20 again, we can't ignore the window to go here, right? Hence you, if you guys are also by yourself doing the algorithms, thinking about the algorithms, you need to first also, like, this point is still important. Even if this doesn't follow here, this point is still important. Like in later examples we will see, like in more techniques we will see how we can reduce the number of repetitive steps here, right? So here, as I said that we don't need to consider the window for this, but now 20 is coming here, right? So we need to still consider the windows here again, right? So we need to make it in a loop, right? So this is how you will also, you guys should also debug your algorithms, your solutions, right? You saw that this is repeated, so you thought ki, okay, what if we don't consider the windows? But then you got to know that if I don't consider the window from first element, this 20 is conflicting here, right? That's why we need to go back again now and consider it from here only. We can't ignore that in the bubble sort, right? So again, now writing, now this is how, if you do these steps multiple times, you will get a sorted array, right? Now we need to again we need to analyze what exactly we did here, right? So what I can write is that at first, like the step 1, what we did, we considered the spacing from 0 to like we went from 0 to n minus 1, right? That was our step 1, right? Now step 2 was 0 to n minus 2. That was our second step, right? uh, yeah, so that I mean, we are basically we are here also we are reducing the spaces, search spaces here, right? So we are just decreasing the search spaces. Now again within step 3, what we did, 0 to n minus 3. And like now we need to write a generic algorithm, right? So we can just say that in step n, what will be the final search spaces? It will be 0 to 1 because that's the last element, right? I mean the adjacent one. Basically this is what we are doing, just like analyze this, what, how exactly bubble sort worked, and correlate this example with this one, then you will understand this thing. Fine, so this is what we need to code right now. Wait, let me, this is what we need to code now. So I can just again provide you guys with a pseudo code of what we did. Wait, just hold on. Yeah. So here I can start with a for loop which is I is equal to n minus 1, because again we are considering it uh, in this way, and we can write I should be equal to or should be greater than 1, right? And I is reducing here, right? Now another for loop we will have here j will be in this way, I minus 1, and j will be plus plus. And now okay, the brackets are already there. Now if you see, if we need to now we need to check, like if array I is greater than array of j, we need to swap it, right? We need to perform a swap algorithm, function basically. So swapping this swap function, you guys can swap using a swap function, you guys can swap these values and then just update till it comes. This swap function, I guess you guys can make it like you can define the swap function using the temp thing which I told you guys earlier in the last lecture. I told you that how to you guys can how swap king can happen between two elements using a third temp, right? You guys are remembering temp, right? So you guys can, I guess, write this swap function by your own self. And yeah, I'm saying the term guys a lot, so I will also stop. Again, now time complexity of it, it is kind of similar. If you if you see this example, we basically are considering this whole spaces, right? So so I can say that we are doing like something like this, right? N minus 2, n minus 3 till 1, right? So basically this kind of forms like a sum of n elements, right? What is the formula of sum of n elements? It is like this, right? And hence if I start solving it, it will be n square plus n by 2 by 2. Now again same thing, I will ignore this, so final time complexity will be n square. Got it? So this will be the final time complexity. And yeah, this is the code, pseudocode, not exactly the code. And I guess again you guys should perform it by your own self. And also now still if you guys didn't get exactly what is happening here, I will again try. I'm thinking to write a full code of bubble sort. So one use case, I mean one case you guys should also consider in any kind of sorting, but for now we will just consider this example, bubble sort example. Let's say that we are given an array which is already sorted, 2 3 5 uh 2 3 5 15 and 20. See, this is already sorted, right? So if like we have to perform sorting, if we are using bubble sort, we need to perform it on an array irrespective of if it is sorted or not. But let's say that if it is already sorted, do you think bubble sort will again go check again and again and again? I mean, although it won't perform the swap function, but those two for loops here, it will run, right? Just to check. I mean, the swapping one won't happen, but the for loop will run. So it will still take the time complexity O n square, right? So now you guys should also understand that how we can like if no swaps are done, if like there's no swap done, there's no need to go for the full array again, right? So that is something you guys should also consider, right? I will write the bubble sort code as well here for your understanding. So I will just write void bubble sort. I will just write this, and we are taking an array, right? And there's one n there's one n shift, yeah. So let's say that we have a loop, right? And I starts from n minus 1. We are decreasing basically, so I is equal to 0, and I plus plus, right? We can have this for loop, and then what we can first, for now we need to also, like, I will just first write the bubble sort algorithm, generic algorithm, and then I will tell you how to solve that thing. Like if the array is already sorted, like if there's no swapping done, then just don't perform these two loops, right? I will explain that as well, but for now we'll just write a generic bubble sort algorithm which will work for every kind of array, right? Now we are in the loop, right? So if array, no, actually there's another loop, right? So we can write another loop for uh, int j is equal to I 0 and j is less than I minus 1. Just you know try to understand this loops. Now if array of, let's say, j is greater than array of j plus 1, because we are considering uh, the adjacent arrays, right? So like first we went into the loop, first we went like inside the loop, right? I mean, first we went into this step, right? I mean, basically what we are doing is that the j steps are going in this way, and this inside is the I term, right? So j steps are in this way. uh, Hence we will be writing code like we are just comparing the adjacent terms. If array j is greater than j plus 1, which means that the smaller array, the smaller is afterwards, so we need to swap it, right? So I can, just maybe I will just write the temp code as well. Wait, I will also write the swap function here only so that you guys can understand. So I can have int, let's say that the temp one is j plus 1, right? And there's one array of j plus 1, which is equal to array of j. Again, what I'm doing is a simple swap term, like considering the third temporary array, element, and just swapping it using that, and j will be equal to temp. So basically we just swapped it, right? uh, and yeah, that's done. And yeah, so this is what basic function as of now. But now we need to see like how, like if there's also an array which is given, and now this is actually really important question. Like it's actually really important case which you guys can be asked in an interview, that if there's one array, like first interviewer can be like, okay, I'm given you are given some random array which is not sorted, like this is not sorted, right? 9, this is not sorted, so you guys can apply, you need to apply bubble sort. So you explained, you wrote this code, bubble sort code. He'll be like, okay, fine, cool, you swapped it and you are returning, yeah, here you can return or maybe form a new array, right? That's fine. But no, it's void, so you won't be returning. Okay, but what if, like, again in this example, let's say in this example the array is already sorted. So still this will, if this function is ran here using in this array, this function will run, and these two, loops will be run. Like, okay, the swaps won't happen because this condition won't match because it's already sorted, right? So swaps won't happen, but this check, like two loops will form, right? So what we can do to not, if there's no swapping, if no swapping happens, you don't, like, no for loops should be executed. So what we can do here to, like, so that the code follows this as well, like if there's no swapping, you don't need to check, you just get out of it. What we can do is, it's simple, it's actually really simple. What we can do here is that we can have one check here. Let's say that this one int, like this one int did swap, this one variable I'm forming, which is, let's say that 0. For now it is 0, right? And I can, like, after this, after just this one more, after just this one, I can write did swap if did swap is equal to 0, what, break break out, exactly, break out of this loop. Basically what we are doing is that this, like when this is coming, there's no swap, so just break out with this loop, like the for j loop won't happen. So basically this O of n square won't have be, like, will be converted to O of n only, because this will only one loop will run. It will just check, like if there's no swap in the first place, it will just break out. Like this condition, did swap is 0, it will just break out. If the swaps happen, this will be updated, and hence basically this will be followed. And yeah, so I mean basically this will work for every kind of array, right? So this is what was the importance of dead swap, and why I wanted to cover this. Right, it's actually really important because interviewer might ask you this, because it's actually really famous thing to ask in bubble sort, or uh, in bubble sort. And I guess you guys can apply this to any kind of algorithm, right? So this is what bubble sort basics is. Also, one thing where you guys can write here, that there are two things which we discussed for now. The worst time complexity, like the worst time complexity is of a bubble sort is O of n square, right? Because if the array is not sorted, you need to go to do two loops, right? Hence this will be O of n square. The worst case scenario would be over O of n square. But the best TC, like the best case scenario of bubble sort, the best would be O of n. Fine, because if the array is already sorted, you just need to go through once. Hence, this is the thing which you guys can should also note down, right? Uh, yeah, fine. So now coming to insertion sort, right? Insertion sort. Let's go to insertion sort now. Insertion sort. Sort. Yeah. So insertion sort. We can now, for this thing I will also write statement so that you guys can just follow. Like here, what we are doing is that I will type it out. Like it takes an element, fine, it takes an element and place like places places it in its correct position. This is what exactly insertion sort is, right? This is what insertion sort is. It takes an element in an array and places it in its correct position. Fine, we will visualize it all as well, right? So let's say that now we have an array. Just hold on. Now we have an array starting from right, like this: 14, 14, 9, 15, 12, 6, 8, and 13. Fine, this is the array. This is the array. We need to perform the insertion sort here. Yeah, insertion sort here. So what we will do is that uh, so let's say that, like, starting from 14 to 9, we can see that we'll first see these two terms, right? 14 9. So this should be swapped, right? So first we will just quickly swap it, and then I will tell you the later terms. uh, so basically we are seeing that 14 9 and 9 should come to the correct place, so the correct place of 9 would be here. Hence we will write it in this way. Fine. Now coming to next terms, 14 15. Okay, 14 9, 14 15. Fine. Now 12. Now till here, where should 12 come? What should be the 12's correct place here? In till here, it should be here, right? So we will just swap it. Not basically swap it, we will I mean basically it should become here, right? So we will swap it with the, like, the adjacent element in, but in like in this way, like 15 12. So basically it will like it will be like 15 12 14, and still this is again, like, you can see that this is still not sorted, right? 14 12 15. So this will again get swapped with the adjacent one. And basically what is happening is that the as the swaps are done happening, it is getting, the elements are getting right shifted by 1 1 1, right? Like, I can't, I mean basically what, like, wait, let me just write it here as well, like 9 12 14 15 6 8 13. So basically this is the new array formed, right? So what we can see is that 12 came to the right place, and the 14 15 right shifted by 1 1, right? As you can see, right shifted by 1 1, right? So like, this is the thing here. Now coming to the next term, 15 6, right? So this is again not following, so we can just swap it
right? So 9, 12, 14, 6, 15. So basically, what is the correct position of 6? 6, it is like here, right? And when the 6 comes here, the correct position, these all the values will get right shifted by 1, 1, 1, right? But like this, in this way, like in this like adjacent one way, this will get swapped. Like again, now 14, 16, this will get swapped. So it will become 9, 12, 6, 14, 15, and later terms, right? Now again 612 will get swapped, 14, 15, da da da. Then again 6, 9, 12, 14, 15. Now you guys can see the pattern. What is happening? The correct element is getting its place. I mean, any element is getting its corrected place, and all the elements after it gets right shifted by 1, 1, 1. This will be the pattern. I'll just quickly write the code. I mean, the insertion sort in my experience is not asked much, but again we need to know all kinds of algorithms, right? So I will just write basically a normal pseudo code for this. We are starting with the I is equal to 0, and we are going with I n minus 1, because you know that thing. Why? Because there's n elements, and like we will have j is equal to I for now, and while now this the condition is really important condition, while j is greater than or equal to 0, right? And and array of j minus 1, basically with j I mean that when we are inside this thing and we are checking, like we came to 6, right? We are checking that if the the element before it is greater or not, right? So because this is how we will check if it is sorted or not, right? Or if it is in the correct position or right not, right? So array of j, this is what we will check. While this is this exists, do swap do swap which elements array of j minus 1 with the array of j, right? With the array of j. And when this is done, j minus minus, basically what we are here doing is that we are moving the pointer back. Like when this is done, move the pointer back and check for then, if when this is done, like this closes and this comes out, and then again j is equal to I, basically the for loop continues in the manner. And then again we check these two elements, then again we to check these two elements, and this happens again and again because we had written a for loop. Got it? This is what exactly is insertion sort, and it is your homework now to tell me in the comments or in the telegram channel what will be the time complexity of this. Fine. You guys should also research. I mean, again, I'm saying don't just depend on one course for your whole DSA journey. I would say that you guys should also explore by your own, and go out in the internet, explore many stuffs. We'll be providing you resources. You guys can check that out as well. Fine. So this is what insertion sort is, right? Next comes the most important one, which is merge sort. So this will be used quite a lot everywhere, and this is actually really really important. I will also tell you, explain you few things about it. It is really actually much better way. It follows something which we call as a divide and merge, not conquer. Merge. So divide and merge method is used here, right? This is the uh, okay, just to follow what in that way I was writing it, I can write it like this, like in this alignment. So basically the point is that it follows the divide and merge concept. How? I will explain you that. Let's say that we have one array, right, which is 3 1 2 4 5 2 6 4. This is some array. It like I have considered this array because it has all types of conditions, because the elements are repeating here, right? And it is not sorted and all, right? So hence I am considering this one. So basically here what we do is that first we find the middle element, like the mid element here. For now the n number of elements are 9, right? 1 2 3 4 5 6 7 8. Okay, I missed one. Sorry, that's why I was like 3 1 2 4. Okay, 1. I'm 1 5 2 6 4. Yeah, now it is fine. Now there are 9 elements, right? 1 2 3 4 5 6 7 8 9. 9 elements, right? Now we need to divide. First we need to what? We need to divide. Now 9 element, the what is the middle of the 9? I mean, the 9 numbers can be divided into two forms, right? It can be divided in 5 4, or it can be divided in the way 4 5, right? I will be following this way because I will be keeping the larger number of array, bigger array in left side. Fine. So what I am doing is that I will be dividing it in this way: 1 2 3 4 5, and these four elements. So basically I have divided them. Fine. I have divided them, and I will be, you know, I will be writing it again. Let me just write it quickly. Like this: 3 1 2 4 1, and here it will be 5 2 6 4. Again we need to keep dividing. Fine, we need to keep dividing. Now 3 1 2 4. Now this is like, 5 terms, so again I can split it to 3, or 3 2 terms, or 2 3, but I will be following the larger number of terms in left side, right? So I will be again dividing it in this way: 3 1 2. This will be 4 1. Fine. Now again more division, because we need to get till the end, right? So this will be simply 4 1. Fine. And no, no, for now I will just keep it like 4 1 only. Now 3 1. Fine. uh, Basically now we need to divide it again. I should divide it in 3 1 and 2. Fine. Now again this is divided as 3 1. So basically now we have divided like this half. For now we have divided. Now it's time for merging it, but merging with one condition to, like, check if it is sorted or not. So 3 1, basically we will form a new, kind of an temporary array. For now, let's say that we have 3 and we have 1, and there's one array we need to form, right? There's one array we need to form. Now in what, like, we need to sort this, like in what way we should put these elements, like, so in a sorted way. So 1 3 will form here, right? 1 3 will form here, and this is what exactly this step will return here. So this will return 1 comma 3. Got it? This is the thing which we will do. This is actually 2. This is 2, just to be clear. Yeah, this is what we do. Now we have 1 3 and 2. Okay, 1 3 and 2. 1 3 and 2, and now we need to form new array. We need to basically add them, but yeah, update the array, right? 1 3 2. How this should be formed, how this should be merged. Actually, this is like two terms, right? We need to merge now. How this should be merged? This should be merged in 1 2 3, and then again this whole step will return 1 2 3. This whole step will return here 1 2 3. Basically this array will get updated. 3 1 2 will get 1 2 3. Now again 1 2 3 4 1, we need to merge. How will it be merged? 1 2 3, right? And then 4 1. How will it be merged? It will merge like 1 1 2 3 4. 3 4 5. 1 2 3 4 5. So this will merge. Now we will get that thing here, and then same thing will happen with this part exactly, right? This part will happen, and then the final merge will happen here. Like basically we will be just, from the temporary array we will be just updating it to the new array. Got it? This is what exactly we would, see it, right? Now let's say that we did this half and we did this half as well, and we got these two terms. We will get these two terms. I will, write it here only. Let's say that we got wait uh, in the final iteration, like when the both halves are done, we will get two halves. First will be the 1 1 2 3 4, which I just showed you guys, right? This will be the one half, and the other half would be like the other half would be 2 4 5 6, like the sorted one. So these both are sorted in a way, right? Let me also zoom it. Right now, like this 246, how it came, like if you guys perform the same thing here, it will get you guys here, this thing, this term you will get. Right now we need to, merge them, the final merge. Now we exactly can't merge in 1 1 2 3 4 2 4 5 6. Like it's simply not merging won't work. We need to, check and check each element if it forms and all, and then merge them, right? So what we can do here is that, we can use something like, we can use pointers here, right? We can have one pointer here. Let's say that blue, uh, just hold on, this is blue. We can have one pointer here. Fine, one pointer here, which will be like first pointer, and this will be the second pointer in this array, second hand pointer. Got it? And now we will have the, the big array, which needs to get these both elements merged, these both arrays merged. Right now, basically what we will do is that we can have a check, like one, we can have first pointer comparing with first and second pointer. So one comparing with first and second pointer, which is smaller, one is smaller, so we will push the one, and we will update this first pointer to the next element, right? And we will keep this second pointer because nothing happened here. One, again comparing the first pointer with the new first pointer with the second, nothing, one is smaller, we will insert it one. Now again jumping here, second, two, two will also come here, right? Now this will get updated here, and this will get here, right? Three, three and four, which is smaller, three, so this will go here, right? First point will go here, and four. Now four, again four, this will go here because both are same, so five. Now this gets here next, because now, but there's nothing here, this array is getting exhausted here, right? This is exhausted, and when this condition comes that the one array gets exhausted, you will simply put the leftover items of the second array in this array, because this is already sorted, right? You don't need to check it because this is already, these both arrays are already sorted, right? We did the merging and dividing and merging, these are all already sorted. So if, and this thing can come in this left, in the right one also, like if this array gets exhausted, if this second pointer comes to the empty, nothing, there's nothing, then just push all the leftover items of this array to the last one, simple. Now this is sorted. This is the, simple merge sort algorithm, right? Now, now we need to basically write the pseudocode for it, right? I will just again, visualize this step. So like now I will first, like, this is a time for pseudocode basically, right? We will write the pseudocode of the whole uh, merge sort array, merge sort technique. So let's say that we have 3 2 4 1 and 3. Fine. And we have something, we can have 0 1 2 3 4. Basically what I'm doing is that I will first consider this array, and we will code out the solution for this. For now, basically just, stick with the solution which I'm telling. We can have these two pointers, low and high. Fine. Abhi, like for now, we, like, what we exactly we did when we got the array. We also found mid one, right? So middle of this will be 4 by 2 because 4 elements. So 2 middle will be something here. This will be the mid, right? And we will, break the array with, again we did that, right? So we will break the array with 3 2 4, right? And 1 3 basically. So you guys can see the pattern, like we are forming kind of tree, and the same thing is happening here again and again, right? So you guys can have this hint, get this hint that recursion can happen. We need to call the merge sort array if we defining a particular function, we need to call it again, because the same thing which we are applying with this array will be applied here as well, right? Hence we will, like, I will start the code right now with the white. I will code it out right here, starting the coding. Yeah, let's say that we have merge sort function which takes an array, and the low and high pointer I have defined already. Alright, it's just a pseudo code. So let's say that
we will be like have we will have some middle here, right? So basically middle will be, let's say that low plus the brackets low plus high by 2 by 2, fine. And then we will basically be doing, let's say this is the function, right? This function. So when we get the middle element, when we get the middle element, we have to perform the same merge sorting application in here and here, right? Hence we will be performing, we will be, calling it a recursive function. But here in this element, like in this new divided arrays, this will be the low, right? As we defined, this will be low, this will be mid, because we have the 4, right? And this would be mid plus 1, right? Any kind of array, if we break with the respect of mid, this the next array will have the first element will be 1 mid plus 1, right? I think that's pretty much understandable. And this will be low. So basically we need to, reperform the, make it, call it in the function again with these pointers, right? So what I can do is that I can make one more thing. I can just call mid plus 1 by which is basically, yeah, array, so sorry, low and mid plus 1, right? And then again I can call the merge sort function to the next, like the other half. So here the half starts from mid plus 1 and it goes till low, right? And finally I can merge them. I can merge these arrays, the new low, new high, and actually mid and high. I will give these terms, I will explain that as well. But for now, did you guys get this thing? Right. Basically, what we did is that we saw the, this is a repetitive function. It's a kind of forming a recursive tree. We are, doing the same thing in the this half and this half. So basically, what we did is that we just, called we just called this merge sort again in a recursive way, but with these two halves. And then in the last step, we are just merging these two halves. Basically, this step, this IEJ pointer, which I did, this thing, this is the merge function which we will define here. So right now, merge function, let's discuss the merge function which we actually did here only, right? Like the merge, which I will just write merge function, which is basically taking array, low, mid and high, right? You guys will get the point. So let's say that we have some temp, we are forming some temp array, right? We are forming some temp array, right? Let's say that I have not defined it, but yeah. So we also have two new pointers, int which is basically left, low, so low, and I'm also defining one right pointer here, right, which basically is the high pointer, fine. Not actually, it is actually mid plus 1, sorry, it should be mid plus 1 because we are having one half here, right? That's why I have defined left, right for now, for one thing, fine. Low and middle plus 1, right, because this is the first pointer of the left, is the left is actually the first half of the first, and the right is the right is the first pointer of the second half, fine. Now we have this while condition, we can run this while condition, while left is not equal to mid. uh, okay, I forgot one condition to write here. It's actually, I forgot really. I mean, whenever you are having a recursive function, you always have to, this is the major thing which I forgot. I'm so sorry. This is the, you need to have a base condition, and in this case, the base condition would be if low pointer is like greater or equal to high, then just, return. This is the, like the last statement, like basically when, when you get all the low and high here, when it crosses, the low crosses the high, right? Just stop, just stop, move out, return nothing, just stop. Like basically this is the base case, we will be doing recursion more often. So just keep these things in mind, right? We whenever we are writing a recursive function, we always have to have a base condition which will throw which will be like check the last condition then just return. Else, like in the last like earlier I forgot to write this, right? So if I forgot to write this, this will happen again and again. There will be like even if the low passes the high, this will again be called and some weird value would be inside the array, right? So that's why it's really important to write the base condition here. Fine. So yeah. So now coming back to here, like hence we are writing like base condition in a while loop here. So while this is this, also right is also smaller than high, because we don't want the pointers to cross themselves for the both arrays, right? So now I can just write the array of left, right? If it is smaller or equal to array of right, yeah, right, then like just add that value. Like how what we did here, we were checking that both the pointers, right? Here the pointer is left and right, right? So both the pointers we were checking, and if it is more, we are less, we're just this is the temp array which we just formed, the temp array which we just formed, and this is just inserting it inside, right? This is what we exactly what we are doing here. Fine. So I guess till now you guys should have that sense of understanding with code, and now you should also try to write the code by your own yourself also, right? Temp add r left, right? Left, I can add that. If the left is smaller than the right pointer, just add it to the uh, new temporary array. Also left plus plus, because when we were doing here, when we were like checking it here, when we were inserting, we were moving our pointer left, but this is for the left condition. We now need to write for the right condition as well. First we will just complete this, like else we also have to write the else, right? Now else what should be done? Else temp dot add, you should add the basically the right pointer. If the condition is not, the first condition doesn't matches, just add the right and right plus plus, because we need to go ahead, we need to check the next element, that's why we are doing that. Fine. So this is done. Now checking for the, now we have to also write for the right condition, like when if the left is smaller than mid, right? So here there's one more condition. Just temporarily add array of left. Fine. Left plus plus, right? So this is done. And then again there's one more condition, like while right is less than equal to high, you need to add temp, you need to add, like when right is less, just add the right one. Simply we are just writing all the conditions which we encountered, right? Oops, sorry. Temp dot add array right. This again is a basic, and whenever you're adding you need to increment your pointer. So this is what basically the code is, simple merge code, right? So just try to write these codes by your own self in your own preferred language. And yeah, till now we are done here, uh, like for the merge sort. And the time complexity also would be like this, the time complexity here would be, so basically what we are doing is that we are getting, we are first we are also iterating through the whole array, right? So O of n for first time, but we are also halving them, right? You guys can see we are halving and applying the recursion, right? Applying the recursion, you guys should already, if you there's recursion also happening, just put the log n. So this is what excuse excuse me, excuse me. Yeah, so this is what the time complexity would be for the merge sort. Fine. So you guys can see, like as we are discussing the the algorithms, we are seeing the merge sort is very it's very efficient than the ON squares of the earlier algorithms which we discussed. Right. Now coming to the last algorithm, which is the quick sort. I will just quickly write it as well. quick sort, quick sort. So this is generally asked. I haven't, like, merge sort is mainly asked. Quick sort you should also know. So I will explain this as well. Now we will learn quick sort. Fine. So basically here also I will use the old convention. Fine. So in, like, here, just remember these things which I will be typing. So uh, here, like, first pick a pivot, pick a pivot and place place it in its correct position in sorted array. Fine. And the next step which you should follow is that smaller on the left and larger on the right. I will explain this. Fine. Like, but this is just like kinda mixed of merge sort and insertion sort. Fine. And it also, like, it also uses the concept of and divide and merge. Kinda. It is like a merge sort, but yeah, fine. So for now, just let's just focus on this. So let's say that we have one array, fine, which is like 4, 6, 2, 5, 7, 9, 1, and 3. Fine, we have this array. So we have this array. Let me do this. Yeah. So with respect to the, like, things which I have written here, we need to pick a pivot, right? So, like, just like for now I will just pick the first element. So we will assume that the pivot is the first element itself, which is 4. So let's say that the pivot is 4. Fine. Pivot is 4. Now we need to pick the pivot. We have picked the pivot, and we need to get this element to its correct position, but in a sorted array. So if this was sorted, how was, like, if we sort this array, like if it is in a sorted form, what should be the order? 1, 2, 3, 4, 5, 6, 7, and 9. Right. So this is the sorted, like the complete sorted array. So the 4 should come here. Right. 4 should come here. Hence, we will be placing 4 here. We will be marking it as like it is correct position. Right. Correct position it is. Fine. Now this step is done. Like, pick the pivot and place it in its correct position in the sorted array. In the sorted array, as in, like, if this array is sorted, the 4 should come here, right? At this position. So I placed it here. But and the next step is smaller on the left and larger on the right, because we are sorting, right? So we can start, like, from next step, like 6. 6 is greater, so 6 would come here. Fine. uh 6 would come here. 4, 6, 2, 5. Yeah. Then again, we see now 2 is smaller, so 2 will come here. Coming to 5, 5 is greater, 5 will come here. Now jumping to 7, 7 is greater here. 9 greater here. 1 is smaller, so 1 will come here. Fine. And then 3, 3 is smaller than. Then the same thing will be applied here. Fine. But now we will divide them. We will be dividing them, because this is considered as a partition, that this is at a fixed position. So we don't need to touch it anymore. We need to just consider this and this. So 2, 1, 3, we will be applying the same thing, right? We have divided it. Fine. 9, we will choose one pivot, which is 2. Let's say 2 is the pivot, right? So 2 will be here, and the smaller will be in the right, in the left, and the larger will be on the right. Fine. So 1, 2, 3. Now here also 6 should come here. So 5, right? 6, 7, and 9. Got it? Now again, do the same thing here and here. Now, are you seeing the pattern now? It is kind of like a recursive tree again. So we will be using recursion here, right? We have to find out the base case, and hence we need to, if we just, like, afterwards, if we just return the sorted ones, we will get the same array, right? Like 5, 6, 7, 9. This will be from 9, 7, 7, 9. and 5. So 5 7 5 6 7 9. This will again return 1 2 3, right? 1 2 3, and we will ultimately will get the sorted array of like 1 2 3 and 5 6 7 9. Got it? So this is the basic quick sort algorithm, right? Now we will like write the code. Try to find the how to write a code for it, right? So for this, I will again use these uh, terms for now. 4 6 2 5 7 9 1 3. Fine. So let's say that we have this array. Coming back to this array, right? Now, uh, like we can have two pointers now. Again, we can have one low pointer, fine, and we can have one high pointer. Got it? One low pointer and one high pointer, and we have assumed that the pivot is 4. So we will be always comparing the 4 element, right? And which is actually a of low. A, where is the basically A is the array, A is this array, and A low, because low is at this point, right? So this is the pivot. Fine. Now with this also we will have two more pointers, which will be I and which will be J, which you guys will get to know why we are using these two pointers again, right? So now we will be comparing, right? So like the I pointer, this I pointer, I will just write it here. This I pointer will checks checks if greater, like the if the element which it is pointing to is greater than pivot. Fine, this, just remember this. Checks if the number which is the it is pointing to is greater than the pivot, and the j checks if it is smaller than the pivot. Fine, and if it is smaller, then it will increment. Fine, this is how the algorithm will work, right? So now we will for now, we our first main job is to like this is the pivot, we need to place it to its correct position in a sorted array, right? So how we will do it? We can do it like comparing the I and j. So like I will check if 4 is smaller than it's greater than pivot. No, it is not. So shift I here. Fine, I is shift. Now 6, is it like greater than pivot? Yes. So stop I for now. For now, stop I. Now j, if is it smaller than the pivot? Yes, it is smaller. So the current I and the current j would be swapped. So the new array would be something like this. Hold on. You get the point what we are exactly doing here? We are just comparing the two elements and then just swapping, but with some conditions which I explained, right? So 4 3 2 5 5 7 9 6, right? Now currently I is where? I is here and j was here, right? Now again I will go here, checking if it is greater than pivot. No, make it here I. If it is greater than pivot, which is 4, yes, stop I. Now j, is it j, is it smaller than the pivot? 1, is it smaller? Yeah. So you again need to swap them. 5 and 1, you need to swap them. So again you will get new array, which will be this 4 3 1 2. I need to swap 5 and 1, right? So this, right? In this way only we will get to know, like now I is here, right? I is here and j is where? J is here. Now I will go here, is it is greater than pivot? Yes, stop I. J, is it smaller? No. Then again j will shift here. 7, is it smaller than pivot? No. Again j will come here. Is it smaller than pivot? Yes. 1 and 7, 1 and 7, right? You guys can see. So we will be hence we can see that the I and j has been crossed, right? At which indexed it has been crossed? It has been crossed to at this index, right? So the new like at whatever condition it crosses, ij crosses, you can shift the pivot to that position. This is the basically the thing. So we can have 1 3 2 4 7 9 5 and 6. So this is the this is the fixed position, this is the correct position of the 4. You got the point? This is how this is how, like it I mean it's still not sorted, right? Like I mean the full array. Now we need to do the same thing in these two arrays which I explained. So this is how we will, when the ij crosses, just shift the 4 with shift the pivot to that point, and hence 4 is the fixed. The same thing will be happen, and for this we will be again using the quick sort function, and we will just write, like this is the low pointer, this will be something, right? We will just write the conditions, and again qs, write the conditions. And here we are not forming another array, right? Hence we don't need to merge them, right? So it's actually just divide, not merge, so that's why I erased it. Fine. We can have we can define the array, like for this step, for to decide what to write in these functions. We can have that thing here, like let's say that we got 132, right? Where was it? uh, I will write it little bit more cleaner way. I 132 4 7 9 5 and 6, right? Yeah, so this is the this is the array which we got finally, like I mean the at after the first iteration which we did. So like here, as a 4 is a like partitioner, we will call it a partitioner, which is part, right? The low pointer would be here. Fine. Basically, low and high just for identifying what kind of array we are, dealing with, right? So, hence, now if we need to search for this space and this space, what will be this and this? Try to think. Easy. We have this partition, right? So can't we write this as part plus one, and this is behind this, so part minus one. Now we got the pointers. Now we just need to place it with the QS this and QS this, right? These two pointers, and you get the point, right? So now I will be writing the pseudo code just for your understanding purpose. Again, it's better always to I mean we will give you guys some questions to practice. There you guys can apply the algorithms, but still before even jumping to questions, write every kind of sorting techniques on your own, in your like own language, preferred language, right? So let's say that we have one function. Fine. I'll be using the code language. Yeah. So we have one function. Fine. And it takes array low and high. Fine. This is the quick sort function. Fine. We need to check first what if low is high, if low is smaller than high, right? Because the condition will run only then. Fine. This is done. Now we have to write the part uh, condition, right? We can define one partition, because right now, like for now, just understand what I'm writing: array low and high. Basically this is just an index which it will give, like now if we get, like basically what we are doing is that we have to ultimately we have to find a partition, and then afterwards we need to apply these quick sort again and again, right? So for now we are just writing the high level code for now, right? So there will be some function which will find the partition, there will be some function which will find the partition, right? That we will write later on. But for now, let's say that we got the partition for some like using some function f. Fine. If we got that, then we can write the QS as array low with part minus 1, because we are quick sorting the first part, then quick sorting the next part. Quick sorting the next part would be part plus 1 high. This would be, and simple, just close it. You are just making it more, right? And this actually is a void one, it's not returning anything, so let's just say that this is a void one. Fine, that's why it's just updating the existing array. Fine. Now writing about the function which we used to get the partition index, like at which index the partition is happening, right? So we can define a pivot here, right, which will be array of low. Exactly, I'm writing exactly what we discussed, right? Like array, like here, exactly here we assume that the pivot is array low, and then we did ij declared and all. I'm just writing those steps, right? So it will be revision for you guys. So again, pivot is defined. Now I will be low, because we are just iterate using high low pointers, right? So high j will be this one, right? So now while I is less than j, because when I crosses it, then that index will be the partition, right? Hence, while I is less than j, right? Okay, and we need to write one more condition, because we need to check the both pointers, right? So two conditions: while array of I is less than array of pivot, right? Array of pivot, and and you can also should also check if high is happening or not, right? Then I plus plus, because we are just moving our pointers, right? Just moving our pointers. Fine, that's done. That's done. Right, now another condition. I will write in the same level, because yeah, again we are comparing with the j pointers, right? If j is greater than pivot, because we are in the with the j is concerned with checking if it is greater, and the I is concerned with the smaller one, right? So pivot j, and j is like, you need to check if it is always, smaller than j, low, then what do you should do, j minus minus. Got it. Now if if I is smaller than j, swap, because we are swapping the existing ones, right? I, and you need to swap basically the I and j terms, right? Done. This is the what function is, and yeah, so this is what quick sort was. So like in summary, we did like every kind of algorithms which is important. There's also radix sort and all, but those are not much important with DSIC interview level things. But you should know the radix sort as well. Like we bubble sort, we did everything, we nearly did. But there's one more thing. Yeah, there's one more thing, which is actually some radix sort, but we won't be covering that for now. It's not much of importance, but you guys should do it as well. So I will be just just go and search, just go, and this will be your homework. Just search, just see what exactly it is. But it won't be, it's not much of important in interviews, with respect to interviews. If your branch is computer science, then maybe in with respect to college exams this is important, right? So yeah, so till now, yeah, we will, so week 3 is done now, sorting algorithms. In the next week we will be covering we will be covering linked list. Fine. So for now you guys should practice sorting, and we will be providing you with all the questions. So again, I'm again and again repeating that if you guys had any, like, this was this recorded session, I couldn't take live today, right? So if you guys have any doubt, please reach out to Telegram channel. Fine, please make that channel active. Fine, you guys can interact with each other. Also practice our uh, S questions, which we will be providing. Fine, every day. It's really important. You need to practice every day. Then only you will, get the hang of it. Right? We will be providing you every day. If you guys have any questions, like any sorting question, you guys can always ping me on the Telegram channel only. I can take that question in the next live class as well. So please, Telegram channel. If you guys have any doubt, please reach out to Telegram channel. If you guys see any question and you can't solve it or don't understand it, please, Telegram channel is there. Right? So yeah. That's all for now, and yeah, thank you.